Assignment 8.3, slope fields. Something like completely new, right? So we're going to practice it. You're going to press pause. You're not going to give up. Try our best, right? So we're going to do a bunch of mini slopes that when you connect them together make a function, a graph or something. We're going to go one step at a time. So if I look at number 1, questions 1, 2, 3, 4, all the way to like 12, I'm going to answer them on this page. So do you see this page, the next one, and the next one? So when I answer it, it's going to be on that page, 1 through 12. So number 1, you're given a slope, and you're asked to plug in these points. So plug in 0 for x, 0 for y, and just solve it. So the answer to number 1, obviously, a is 0 when you plug it in. When you plug in 1 for x, 1 for y, it's what, -1. For c, -2 and 4. Is that +2? Just double checking. D, 4 and -2. Be careful. What was that? -4. If you simplify it. E, -3 and -3. It's going to be a fraction. Was it 9 over -5? Can you do it mentally to do the substitution? F, 5 and 12. So that's 25 over 10. What is that? 5 over 2? Yeah. Okay. So we're just plugging in points into a formula, simplifying it, really simple. For the differential equation problem 1, why are there no slopes when y equals 2? So when y equals 2, the slopes are undefined. So obviously if you have a 0 in the denominator, it's undefined. So when y equals 2, the slopes are undefined. Number 3, the slope field, and you're given a slope formula, x over y, and then at the right is a slope field given. And then in part A, it says, can you do it? So I'm going to switch over to the actual book in terms of what's happening. And then we're just going to try, so I'm just going to write these out on the side. So 1, 2, 3, 1, 0, 3, 0, -2, and -2, -1. This is one of the hardest things to like conceptualize. So we're going to try to do it slowly and have a good attitude about it. So, by the way, here it is, right? The answer is for 1, and then when y equals 2, the slopes are undefined. Simple. All right, so I want to draw the picture of the function through these points by following the slopes. So think of this like a river, and you're just floating along, and the direction the current is taking you is how you draw it. It just takes some time. So I'm going to start at 1 and 2, which is like right here. And then what's happening to the right, and then what's happening to the left. So if you follow the slopes to the right, follow the slopes here to the left. So to the right, they're rising. To the left here, it's falling. Now what happens right here, a horizontal slope is a turning point. So it's going to turn and then follow the slopes, and you have the picture of what's happening. What's happening at 3, 1? So here's 3, 1. So what's happening to the right? Which way is it going? So I just want you to know, if you see the slopes, just follow what the slopes are doing. Now, this is going to lead to here. Now notice there's no slopes on the axes. So as it guides you to the axes, that's it. There's a hole there. It's not going to cross over and not be a function. See, if I follow the flow of the slopes, it has to still pass the vertical line test. So I can't have something on top of each other. So there's the hole, and that's it. And the slopes are undefined there, so it just stops at the hole there. 0, 3, I can find that. So 0, 3 is a horizontal line segment that gets a horizontal slope. That is the turning point. So it goes up to the right, it goes up to the left, and you kind of follow the angle of the slopes. But that is the turning point. Here, we had to get to the turning point, and then it happened. What's the next one? 0, -2. Here, again, it's a turning point because it's at a horizontal slope. So you have your curve, and you draw it. And then, what's the next one? -2, -1. So again, follow what it's doing. And then as you follow the slope, make sure, as this curves, that as it's curving to the axes, it's a hole. It's not going to continue and curve and make a C at all of any sort. I think that's all of them. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's it. So I know that takes some practice. And then D says, can you solve this? X divided by Y. So how do you solve a diffie-q? Change it to dy by dx. Separate the variables. We're going to multiply by y and dx. So separate the variables. Integrate both sides. So that's y squared over 2, x squared over 2. And then does it ask to solve for something specific or just the general solution? Oh, what would the look at 2, 2? Did I do 2, 2? I don't think I did 2 and 2. Oh yeah, I see it. Okay, so it says, what would it look like? Part C says, what would it look like containing 2, 2. So I want you to look at 2, 2, and notice it's just a line, y equals x, if you follow it. So it would just look like a line. That's what it would look like. So 3D, solve that equation, and there'll be plus c a part of it. Honestly, we don't have to go further than this. So that's a good answer, and you can let it go. All right, 4. In question number 4, make sure I have the slope formula. It says dy by dx equals, I'll do that on the side, dy by dx equals y. So just the y coordinate tells you the slope. And then can you complete the slope field just using the y coordinate? So whatever the point is, just look at the y and that's the slope that you draw. So let me see if I change colors, it'd be easier to see. Let's just start easy. So when the y coordinate is 0, that would be like along the x-axis. All of these, when y is 0, a 0 slope is horizontal. So along the axes, at every point there, it's 0. Here, and we could just work our way up row by row. So the next row up, the y's are 1. So 1 is up 1 and over 1. So see if you can draw a mini cute little slope of 1, up 1 over 1. Now here's the most important part. If a slope of 2, it has to be steeper than what you just did. So as you do it, make sure the next row is steeper in comparison. And then at 3, it's still steeper yet, right? So then you're still drawing it in comparison to the row below it. Underneath, -1. So there's the slope for -1. Down 1 and to the right 1. And then if you do 2, it's steeper going down. And then 3 is steeper yet. And it just takes practice to be able to draw slope fields. Right? So there's your slope field. Then I'm going to use black here. What's the slope here? So this is 3, 2, 1, 0, -1, -2, and -3. So you drew it. That's A and B. And then it says graph the particular solution through 0, 1. Let me just write that down. And 0, -1. So if I start at 0, 1, it's right here. And notice what's happening. So to the right, what's happening? And then to the left, eventually it flattens out. What does that curve remind you of? Anything? That curve right there, what does that remind you of? So to me, it reminds me of a exponential, right? Where it rises to the right and it flattens out to the left. The other one is at 0, -1. That's this one here. And this one flattens out like this, but then goes like that. Follow the slopes, right? One slope is flat here. Follow the way the current of the river goes. And then I think in part C it says, solve the diffie and the particular solution for 0, 1 and 0, -1. So let's do that together. So can we solve this diffie? So it's dy by dx equals y. So not that bad. I need to separate the variables. So I'm going to divide by y, multiply by dx. I'm going to integrate both sides. The integration of 1 over y is a logarithm. You don't see anything there, but it's 1, and the integration of 1 is just x. And then I'm going to write that as an exponential. Remember this, right? It's really, this is how you can separate it. And then as you separate that, you can redefine the constant. And that could be, to remove the bars, it could be positive or negative e to the c. So positive or negative. And then I can just redefine it as c2 e to the x. So remember we said, what did it look like? It looks like an exponential, right? That's e to the x. Then I can solve for the constant by plugging in the numbers. So 0, 1, the first thing I would do is 1 equals, and then plug it in. Now, e to the 0 is 1, so c2 would just equal 1. So one equation would be e to the x. That's through 0, 1. And if I plugged in 0, -1, then c2 would just equal negative. So it would be y equals -1 e to the x. So the first graph you drew was y equals e to the x. And the second graph you drew was y equals negative e to the x. Just reflecting over the y-axis. All right, number 5. Oh, there's your tear out sheet. So for the diffie, it's x divided by 2. Draw the slope field. And then graph and so on. So let's do the slope field first. Let me write that down. So dy by dx equals x divided by 2. So it's only the x coordinate. So it's going to kind of go by columns. So if it's only the x coordinate, then think of them by columns going down. So the first column I go to is 0. So when x is 0, that's the middle column. So if you plug in 0 for x, the answer is 0. So again, I'm going to change colors here. So I'm going to make this a 0 slope means it's a horizontal slope. So when x is 0, the slope is 0. How about positive 1? It's 1/2, which is kind of like up 1 over 2. Up 1 over 2. And try to do your best to draw them at the same angle of what you think is up 1 and over 2. Here, when it's 2, then the slope is 1. So up 1 and to the right 1. Here, -1 would be -1/2. Kind of a flatter slope. And then -2 would be -2 divided by 2, which is -1. So down 1 and to the right 1. So there's your slope field. Then, the next part. Draw the solution through -1, +1. So -1 and +1, that would be right here. And so what direction is it going? So can you get a sense of it? Now once it curves to here, along this axis is a turning point. So then it's going to turn and then go up following the river. So that's what it's going to look like. I have my answer key here too. And then you have to solve the diffie that goes with that point. So there's the curve, knowing at the axis is the turning point. And now 5c, can you solve that diffie-q? So separate the variables, multiply by dx. Integrate both sides. So that's y equals, so add 1 to the exponent, and then divide by that, and then plus c. So I get x squared over 4. And then plug in the point to find it. So the point we went through again was a negative 1, 1, right? Yeah. So plug in negative 1 and 1. So subtract a quarter. 1 take away a quarter is 3/4. You should know that. And then the equation would be y equals x squared over 4 plus 3/4. There it is. So it's just a parabola. So if you look here, it kind of looks like it goes through 3/4 would be where the vertex is. All right, number 6. Repeat 3 parts of problem 5 for the diffie-q, and I'll write that down. So now the diffie-q is y prime over 1 over 2y. And for this problem, draw your graph and write a solution as a function of x. Oh, so we're still going to use negative 1, positive 1. I was just double checking. Oh, wait. So, make sure you can see it. So there's the diffie-q we're going to plot. So because it's y, we're going to go by rows. So when y is 0, it's undefined along the x-axis, so it's empty. When y is 1, it's 1/2. So let's draw one that's 1/2. So it's up 1 and over 2, kind of flat. Up 1 over 2. Maybe this is the artistic side of calculus. Plug in positive 2 and you get a quarter, so that's even flatter. Up 1 over 4. Here, if you plug in negative 1, you get negative 1/2. And then you get negative 1/4, which is not a flat line, but you know, it's getting closer to that kind of a line. So here, if I wanted to label it, this was 1 over 4, this is 1 over 2, this is negative 1 over 2, this is negative 1 over 1/4. And the most important part is that this has to be flatter than this, right? It's comparative. So if this is really 1 over 2, then 1 over 4 would be flatter and vice versa. And try to be as accurate as you can. Now, through negative 1, positive 1, it'd be right here. And so if you follow the flow in terms of what's happening, this is kind of what the flow is going to. So it almost looks like a square root function. But notice that it has to be, once you hit the axes here, it's a hole. You can't continue and make like a C pattern. So you have that hole, follow the flow of the slopes, and you have the sketch through negative 1, 1. Now we're going to solve the diffie-q. So dy by dx equals 1 over 2y. We're going to multiply by dx and 2y. Just do it in one step. We're going to integrate both sides. So we have y squared divided by 2. Now 2 divided by 2 is just y squared. And then that's x plus c. At any time you can plug in. So I'll plug in now. So we have positive 1 and negative 1. So if I solve for c, add 1, I get c is equal to 2. And now we write y squared equals x plus 2. And then to get y by itself, you square root. Now recognize the answer could be positive or negative. What determines it is the y coordinate. So because the y coordinate is positive, it's positive in front, and that's the equation that goes. Now, does it make sense that this equation goes with this? Certainly, right? Look at it, right? So I already said it kind of looks like a square root curve. All right, number 7. So number 7 is repeat the 3 steps above for 5, and now we have a different one again. Again through -1, +1. Let's practice again. So we have a different, what's the diff EQ here? So I need to get y prime by itself. So I'm going to divide by y squared. So it's 1 over y squared. I'm going to do that first. And again, because it's y, it's going to go by rows. So 0 is undefined. +1 goes up 1 and to the right 1. And then 2 would be up 1 and to the right 4. Sorry, should be flatter. -1 gives you the same answer as above. And -2, when you square it, again, up 1 into the right, it's a little bit flatter. There's up 1 into the right 4. Through -1, +1, there it is. And then follow the flow to the right. And the flow here, make sure you stop here at the axes when you follow the flow. So there's the equation. The diff EQ that comes from that. So we're going to solve that. Multiply by dx and y squared. So you have dy at y squared and dx. And you multiply, integrate both sides. Sorry, the order is a little bit off there. So it's y cubed divided by 3, x plus c. At any point you could plug in. So I'm going to plug in +1 and -1 to solve for c. So to get c by itself, I'd add 1 to the other side. So it'd be 4/3 or 1 1/3. Try doing that right. And then I go back here. And I still need to get it by itself. So I'm going to multiply everything times 3. And then I'm going to cube root it. So that picture is part of a cube root. So you have the cube root of 3x plus 4. All right, 8. Let's see what the diff EQ is for 8. So for 8, there it is, a little more complicated. This one involves both the rows and the columns. So this takes a little bit longer to calculate, but we can do it. So dy by dx equals 2x y minus 1. So I stick to where the slopes are 0 to begin with. It says use the origin for this one. So we're going to use 0, 0 for this one instead of -1, +1. All right, so where are the slopes 0? Oops. So when y is +1, it's 0, so that's a good place to start. When x is 0, it's also that way. And then just see if you can see a pattern. So here we have a point 1, 0. So if I plug in 1 and 0, it would be -2. If I plug in 2, 0, I get -4, so even steeper. On the other side, -1, 0 would be a positive. So there's a reflection here. And I think you're going to see a reflection all over. So at 1 and 2 would be 2. And at 2 and 2 would be 4, so that's even steeper. And then on this side will be a reflection of that. So if you reflected it over. In fact, all of them are kind of like that. So 1 and -1, what is that, -4. Some of these are going to be ridiculous. So 2 and -1, I mean, that's even steeper yet. Here, 2 and -2, That's 4 and negative 3. I mean, that's negative 12, right? I mean, that's just ridiculous steep. Same thing here. It won't be quite as steep, but still steep. So there's our slopes, and kind of see a pattern of how the slopes are going to go in comparison to each other. They said do it through the origin instead of through here, and then notice how the slopes go if you follow them and what it looks like. So there it is. Then if we take the diffie-q, can you separate the variables and solve it? So we're going to multiply and divide. So we're going to divide by y minus 1 and multiply by dx. We're going to integrate both sides. This is ln. This is x squared. You know to write it as a logarithm, or sorry, as an exponential. You know that we're going to write this here as e to the c times e to the x squared. And then to remove the bars, it'd be plus or minus e to the c times e to the x squared. Then we're going to redefine it, so it's just one constant there. So plus or minus e to the c is now that. So we've redefined the constant. At any point, we could plug in and solve it. So 0, 0. If I plug in 0 for x, so this is what we have right now. I have c2e to the x squared plus 1. So if I added 1 to the other side, if I plug in 0 for x and 0 for y, e to the 0 is 1. So it'd be 1 times c. So e to the 0 is 1, so this is what you'd end up with. So if you subtract 1, you can see that c2 is equal to negative 1. So if I put this together, it would be negative e to the x squared plus 1. All right, 9 and 10. So in number 9, the slope field for a certain diffie-q is shown at the right. Which of the following could be a specific solution to that diffie-q? So first of all, if you take a point and try to draw through it, it can maybe help to understand what could be the equation that could match it. So what does it look like? What does it not look like in terms of it? So for number 9, it goes up to the left and down to the right. So it looks like an x cubed. So does it look x squared plus y squared be a semicircle? It does not be a semicircle. X squared subtract y squared is kind of like a sideways one, like a hyperbola. 4 over x would be undefined at x equals 0. Nope. And then y over x, same thing. It would be undefined. Well, if you multiply by x, you could have y equals 4x would be like at 4. So really the only one that could match is 9 is A. If you get y by itself, subtract the x cubed. A negative x cubed goes down to the right and up to the left. It's the only one that could match it. Just thinking it through with me. For number 10, you have a slope field. And which of these diffie-q's could match it? So there's nothing that's undefined. So therefore, C and D are gone because we have undefined values. The difference here, pick a point and see if it would work or not. So like right here at 0, 0, the answer should be 0, which it is. How about at 1, 0? The answer should be, so if x is 1 and y is 0, the answer should still be 0. So that's only true for E. So that's the only one I see that can match. So try to take a point off the origin and test it to see if it works or not. So I tested 1, 0, and 1, 0 when you plug it in. The only one that would give you the answer 0 is E. Number 11. This will be our last one for this video, and then I'll do 12 and on, which are all review kind of questions. So for number 11, Oh, why not? We'll graph it right on here. So number 11's review. So number 10 was the last one with diffie-qs and slope fields. Number 11, can you graph a cube root? So I see -1 and 0 is a place to start. So start at -1, 0, and then adjust it. So it's going to have, if I plug in 0, the answer is 2. If I plug in -1, the answer is 0. Sorry, if I plug in -2, the answer is -2. So here's what I got. So there's the point of inflection. And this is what it's going to look like if you graph it. Whoop. And then it says, find the inverse. So to find the inverse, we're going x equals 2 times the cube root of y minus y plus 1. And then we're going to solve for y. So to solve for y here, divide by 2. Cube both sides. And now subtract 1. So the inverse there would be x divided by 2 cubed, subtract 1. That's what it would look like, the inverse. And then it says graph. I think it says graph the inverse on there. Yeah. And what does it reflect over? Y equals x. You know that already. So if I was going to do this, take the points you have and just reflect them. So we have -1, 0, so 0, -1. We have -2, -2, so it stays on that point. We have 0, 2 becomes 2, 0, and so this is what it looks like. Oops. Up that way. Sorry, it goes like this. That way. And what line should it reflect over if I was anywhere accurate? It's y equals x would be the line it reflects over. All right, no more of these teraweed. Now you got to go to your notebook. So this was actually in your book. And now the rest of the questions you actually have to do here. You know what? I'm in the mood. Let's just get it done. So number 12. Let's see how far. I may not be able to finish it all in one shot. So if I can, I can. So the limit as x approaches a of x subtract a over a squared subtract x squared. So for this, if I plug in a for x, it is indeterminate. So I'm going to factor it. A plus x, a minus x. X subtract a and a subtract x are opposite factors, so it leaves you with -1. Now you can plug in a, and you get the answer -1 over 2a. Done. Number 13, you're asked to find this limit. That's a greatest integer limit. So at every, and I draw them with a double bar, so I'm not sure exactly the symbolism there, but here, whatever. That's how I draw the greatest integer. So at +2 is an integer, and then there's going to be a jump. So it's the greatest integer less than or equal to that, right? So from the left, what's going to happen? So if I plug in 2, the answer is 1. So on the right, that's where it jumps to. So when you plug in 2, it jumps up to 1. So on the left, where did it come from? And the integer before the 1 is 0. So it kind of looks like this. At 2, it jumps up to 1. It'll be a hole. It's right here. This is where the hole would be. And then like that. So as you plug in numbers up to 2, the answer is 0. And then when you plug in 2, now the answer is 1. So the limit on the left is 0. On the right is -1. Now at 14, it just says, what's the limit as x approaches 2 as a two-sided limit? So if there's no plus or minus, because of this jump, the limit does not exist because the left and the right, they don't agree on the answer. Number 15, this is a question to do with right end behavior. So the limit as x approaches infinity. What's the power term on top? Oops. And on the bottom. So let me just write it out. Just be careful of the power term because you have exponents. So that's equal to the power, that's equal to, if you just saw the power on top and on the bottom. So this is x squared times 3x. So it's 3x cubed. This is 4x squared times x, which is 4x cubed. So the x cubes divide out, and the right end behaviors go into 3/4. Number 16. You have the derivative of that. Find f of t. So the derivative equals this. That's the definition of a derivative. Can you work backwards and just tell me what f of t equals? Now, it's actually way easier than you think. So this is the derivative formula using limits. This part on the right side is what f at x is. So this is like f at x plus h minus f at x over x. That's the formula. So if I just want f at x, or in this case f at t, it's just what's on the right side here. It's t plus root t. That's it. And then don't forget the candy. So by definition here, that's t plus the square root of t plus c. So you're given the derivative as a limit. Remember your formula for a limit to find a derivative, which is, I know, a long time ago. This right here without the h's gives you what the function is, and then add the constant. Number 17. Find the x values where the function is not differentiable. All right, these will be pretty quick questions. So in this case, it's not differentiable. What would be number 17? Oh, at positive 3 and negative 3. So when x equals positive or negative 3, so if I take this and make it equal to 0, that's the answer you get. Why is that bad? Because there you have like corners. So the graph of this, the graph of x squared subtract 9 would actually look like this. But the absolute value bars takes what's there underneath and reflects it up. So it actually looks like this. That's what the graph looks like. So at these sharp corners right here, that it's not differentiable there. And you can think of it also like a limit, where the left side does not equal the right side there. But we have sharp corners. And you can see that the left and the right don't agree. All right, number 18. Greatest integer. So g at x equals. So what makes an integer here is all halves, right? So multiples of 1/2. So multiples of 1/2 create jumps or discontinuities. That's why it's not differentiable there. Number 19. Where is this not differentiable? So what we're looking for is where it's not continuous. So at x equals 0 and -1, it's not differentiable. And why is that? So at 0, notice how the x is crossed out, so there's a hole there. That's the reason. Negative 1 remains. It's non-removable, so there's a vertical asymptote. And you can't take the derivative at a whole or vertical asymptote where there's a discontinuity. Number 20. So x subtract x cubed. For this one, it's probably easiest just to take the derivative and see it. And you can see at x equals 0, the derivative is undefined. So when you have a negative exponent, it belongs in the denominator, and 0 would make it undefined. 21. There's a vertical tangent there. A vertical tangent means it's continuous, but the graph has a vertical part to it. 21 for the tangent. You have a piecewise. So there's your piecewise. So we're looking at each piece is continuous and differentiable. What happens when you plug one into the top and one in on the bottom? Is there a jump at all? So it is continuous. So if you plug one into the top and one on the bottom, they actually both equal 3. So that's fine. What happens when you take the derivative? I get 2 on top, and the derivative on the bottom would be x plus 1. So 2 times a half is 1. Subtract 1 to the exponent. Derivative of x is 1. Now when I plug 1 in and 1 in, they have the same answer. So for h's, there is h of x is differentiable. Across the entire domain. So h at x is differentiable across the entire domain. So there's nothing that doesn't make it differentiable. All right, number 22. If a particle moves along the curve y equals x to the 2/3, and the derivative of x with respect to time is 3 for all x, find dy by dt. So take the derivative with respect to time when x equals -1. All right, so this is what I'm doing. Here. So take the derivative with respect to time. So take the derivative, and then it has that hook. In the question it says x is -1. And dx by dt is 3. And then to simplify it. Now, +1 to any exponent is +1. -1 to any exponent is a -1, if it's a negative exponent like that. So if you multiply this through for 22, you get the answer -2. So the 3's divide out, and then you're left with -1 times 2. For number, that's part A. For part B, find the dy when x is 8. So plug in 8. So could you simplify this if you had to? So the cube root of 8 is 2, but the negative exponent makes it 1/2. So the 3's and the 2's, that just leaves me with 1. Is that right? Part B? Yep. Part C, find dy by, find the limit as it goes to infinity of that. So what does that mean? So as you plug in huge numbers for x, remember this is and this is 3, right? So because that's 3, really it's 6 over that. That's what it looks like. So 2 times 3 is 6. and write it as a negative exponent cube root. So as you go to infinity, the denominator will be more powerful than the numerator. So this is going to go to 0 as it goes to infinity. And now d, what's the limit as x from the left side for 0? So from the left, so here we are, right? So what would happen if I plugged in -1? Whatever, it would be a negative answer, right? So from the left, there's a asymptote at 0. So this is going to be negative on the left. So this is going to negative infinity, or you can say it doesn't exist. So at 0, there's an asymptote. On the left of it, it is going down forever. So you could say negative infinity, or it doesn't exist. Both would be correct. All right, 23 and 24. We're almost there. So at 23, it says use a tangent line to the graph of y equals x to the 2/3 to approximate 8.1 to the 2/3. So I'm going to use x equals 8. If x equals 8, the cube root of 8 is 2, and 2 squared is 4. And then I'm going to take the derivative of this, which is 2/3 x, subtract 1, negative 1/3. And then I'm going to find the slope of that. So if I plug 8 in, what's the slope when you plug in 8? So the cube root of 8 is 2, and the negative makes 1/2. So the 2's divide out. I get 1/3 to be the slope. So the equation would be 1/3 x subtract 8 plus 4. That's what the equation would look like. And then to estimate 8.1, you plug in 8.1 and then solve it. So it's 1/3. 0.1 is 1/10. So if I put this all together and multiply it, 4 plus that would be 4 and 1/30th. And then part B, what does part B ask? Why could a tangent line at x not be used for it? And so the problem with that is there's no tangent line at 0 because the derivative is undefined at 0. So there's no tangent line there. So that's A. B. So why couldn't you use 0 as a point? Is because the derivative here, if you plugged in 0, because of the negative exponent, this is what it looks like. That's the same. And notice that x makes it undefined. So the derivative is undefined at 0. That's why you couldn't use the 0.00. All right, last one, 24. Without using a calculator, sketch this graph. All right, and we're not doing any calculus. So they're not talking increasing, decreasing. They're not talking maximum, minimum. They're not talking point of inflection. Just do pre-calculus here. So we're going to factor out a 2x, factor out an x, and then keep factoring. So x squared subtract 1, and x squared minus 4. So both are a difference of squares, so just factor it completely. So you can see the x removed. So we have a hole at x equals 0 because it got removed there. And then if I plug 0 back in for the hole, you get the answer 1/2. So plug in 0 for x everywhere. Reduce it down, you get 1/2. What remains are vertical asymptotes. So we have one at -2 and +2. The domain, I guess we shouldn't leave that out right away. So the three numbers x can't be are 0, +2, and -2. That's what makes the bottom undefined. That's what these come from. Look at the numerator. -1 and +1 are x-intercepts. What's left? Y-intercept. If you plug in 0, it's undefined there because we have a hole at 0. So there's no y-intercept. What did I leave out? Type of symmetry. End behavior. That would be helpful too. So notice the end behavior. You can go at the beginning. Power over power. The horizontal asymptote is at y equals 2 when you divide it out. So that's going to be helpful. So now let's put all the pieces together. So and now finish the graph. So we have a hole at 0 and 1/2. We have an asymptote at -2 and +2. We have an intercept at +1 and -1. And now what's the direction this goes? So I can already give you a sense of it. And then at 2, that's the end behavior. So connect what you have here and the end behavior that you have. Notice that the asymptotes are odd. So if it goes down here, it's going to go up over here. And then the end behavior. Same thing here. If it's below here, that's an odd asymptote. So it's going to be up the other way. Remember, odd or even means the exponent, right, that it comes from. So for an x-intercept, it crosses over. For a vertical asymptote, they go in opposite directions. So if it goes to -infinity here, it goes to +infinity, and then it curves to the end behavior, that's 2. And there's your graph. A little pre-calculus for you. All right, Mr. G Math, over and out. Till next time, proud of you for doing your work.